All right, today we're going to cover as much as possible around our antivirus for Amazon S3 solution. We'll do a really high-level overview of the architecture. We'll take a look at the management console, and we'll also get an understanding of what happens in the background when we're ingesting your storage volumes, protecting them, and scanning the data within them, and what will happen as those scans occur. Now, when you deploy our solution, you can do so either through a CloudFormation template or using Terraform. For the purpose of simplicity, I will stick to CloudFormation for today. Running that CloudFormation template, we will deploy resources in a number of different AWS services that we use to power the solution. One of those services is ECS Fargate. And what we'll do within Fargate is we'll stand up an ECS cluster that will contain a console service. This console service is what will be hosting our GUI, our management console, essentially. And that management console is what you'll use to log in and configure the solution, protect data, so on and so forth. Now, when that management console is deployed, what we'll do on our side is we will ingest all of the different storage volumes that we can see on the AWS account that you're deploying on. So you'll be able to see all of your S3 buckets, your EBS volumes, EFS volumes, FSX volumes, so on and so forth. And when we ingest all of your volumes, you have the option to protect them a few different ways. The main way you can protect a storage volume is through what's called event-based scanning, so scanning of new data. And for the purpose of simplicity, I'll mainly stick to S3 buckets for today. But please know that a lot of these concepts that we're covering can also apply to EBS, EFS, and FSX volumes. Now, if we want to scan new files that are being written to an S3 bucket, all we have to do is find the bucket that we want to protect and scan data on, and we can select this red shield right here. And what happens in the background when we click that shield is we add an event listener to that bucket. Now, when we add that event listener is subscribed to an SNS topic, and that SNS topic is in turn subscribed to an SQS queue. Anytime an object is uploaded to the bucket, an event is raised and sent to that SNS topic. The SNS topic sends a message to that SQS queue. And that message contains details around the path of the file type, the size of the file, so on and so forth. And when protection is enabled for a bucket in a specific region, what we'll do is we will also stand up a separate ECS service that will act as a scanning agent or set of scanning agents that will be hosted in this ECS service. And that's called the event agent service. Now, the tasks that are scanning agents in this service will be listening for any messages that are sent to your SQS queue, and they'll be picking up those messages and interpreting them. What happens in the background is we will use the S3 API to pull the object from the bucket and write it to the disk of the scanning agent. The scanning agent will then perform a scan and return a result. Once that result is returned, we'll write it to a few different areas. Number one being the object itself. Now, that object will be tagged at least twice. One will be a scan result tag, and the other will be a date and time tag. And once that object is tagged, that is how you know through those tags that the object has been scanned by our solution. We'll also write findings to CloudWatch. Within CloudWatch, there will be a specific scan results log group that you can also see any scan result details within. Within your management console, we don't surface clean findings because we expect most of your data to hopefully be clean. However, we do surface problem file findings. So any files found to be infected, found to be unscannable because they're password protected or encrypted, or found to have an error from the scan because the file was corrupt for some reason or inaccessible, all of those findings will be surfaced here on this problem files page. On this page, you'll be able to see the path of the object and the bucket that it's in. You'll be able to see the finding itself and how each scanning engine that we use and have identifies the malicious finding. Additionally, you'll also be able to perform what's called static and dynamic analysis on an infected object if you wanted to. Now, all this is cloud detonation. You're able to send the file to be analyzed. And what will happen is you'll get a result of that analysis. So you'll be able to see the reputation of the file. You'll be able to see details like what IP addresses it's trying to connect to, what directories it's trying to write to, or what files it's trying to execute and commands it's trying to execute. And this is a great way to get an idea of what the file is trying to do without having to download it to your local machine, write it to a VM, and test it in there. You can do a quick analysis through our static and dynamic analysis functionality to see what the file is all about and get an idea of whether or not it may potentially be infected or whether or not it needs additional analysis from your side. When a file is scanned, you can also surface findings on that file through our proactive notifications functionality. And what this allows you to do is it allows you to set up a notification for any type of finding. We usually recommend notifying for error, infected, unscannable, and infected allowed. And this way, anytime a file is tagged with any of these types of results here, you'll be able to notify to an email address, a text message, a HTTP or HTTPS endpoint, an SQS queue, or even a Lambda function. And the sky's the limit with what you can do with these notifications. You can process them any way you need to or see fit. You can also integrate this to send notifications to Slack or Teams so it can be a part of your SOC, your Security Operations Center, and people can see the notifications in real time as they come in to your Slack or Teams chat. Now, in addition to scanning new files that are uploaded to S3 buckets on an event basis, you can also scan pre-existing files that are stored in a storage volume. And this is what we call retro-based scanning, scanning of pre-existing files. You can do this one of two ways. The first is you can do it on demand, where you select a bucket, you select a storage volume, and you immediately click Scan Existing, and you have the option to scan all of the pre-existing files that exist in this storage volume at this time. You can select a specific date range if you wanted to, whether it's all time from the beginning of S3's existence or to a more specific date range like the last 30 days. And what you can do here is you can scan all of the pre-existing files in this bucket to understand whether or not any of those files are infected. This is a great way to create a baseline for your data and know that all of your pre-existing files are clean, and through our event-based scanning, know that any of your new files that are being uploaded are also clean. The other way you can scan pre-existing data is on a scheduled basis. Now, a lot of our customers have specific requirements, whether it's due to their organization requiring it or specific security frameworks like SOC or HIPAA requirements that force you to scan pre-existing files on a scheduled basis with a specific frequency. Similarly to our on-demand retro scanning, you can select which storage volumes you want to scan. And from here, what you can do is you can set a frequency of how often you want this scheduled scan to run. You can do it from every half hour all the way to monthly or even yearly. And you can set it to even be multiple months out of the year as well. So if you wanted to do something quarterly, you could do so pretty quickly through our scheduled scanning functionality. Once you set the frequency, the scan period that the schedule will run on, and you save it, every time it hits the specific frequency that you've set, a scheduled scan job will kick off and scan all of the pre-existing files in the storage volumes that you've associated with this schedule. Now, one thing I want to point out for today is you can also do a lot in the background to decide how you want these files to be treated. When an infected file is found, you have the decision to either keep that file in the bucket that it was uploaded in. You can also quarantine the file if you wanted to as well. And this is our default functionality, our default behavior. We stand up separate quarantine buckets in each region that you are protecting data in. And anytime a file is found to be infected, we will move it to this quarantine bucket. In the problem files page, what you'll see is the ability to allow infected files through either once or permanently. Once meaning the file is allowed through this time, and the next time it's uploaded and scanned, it will be caught as infected again. Or if you allow it permanently, the next time this file is uploaded and scanned, it will be allowed through to your destination bucket. So it's entirely up to you how you want to control infected files being handled. You can also set the file handling to delete files automatically if they're ever found to be infected as well. With our solution, you can also utilize multiple different scanning engines that we have available, and it's entirely up to you which scanning engines and how many you want to use. Each scanning engine is a little bit different, but it's entirely up to you. We can scan files up to 5 terabytes in size, which is the S3 maximum limit for a single file that's uploaded into your bucket. Along with everything we've covered, what you can also do is you can also utilize what we call our 2-bucket system. Our 2-bucket system allows you to set a specific bucket that you can use as your what's called dirty or landing bucket. And that landing bucket is where files will land in when they're uploaded to the bucket, and they'll be scanned. So that's the bucket that you'll protect for files to be scanned. And once they're scanned, if they're found to be clean, what you can do is you can set a destination as a destination bucket and have that clean file sent to that destination bucket. If the file is found to be anything other than clean, then we wouldn't move it to that destination bucket. If you have a requirement to only have clean scanned files within your destination production bucket, this 2-bucket system is a great way to meet that requirement, because you'll be able to only write clean files to that production clean bucket. Really quick, I'll cover a few other pieces in terms of scanning. We've talked about scanning files that are newly uploaded to your bucket, and we've talked about files that are pre-existing to your bucket, but we should also talk about being able to scan files before they're ever written to a storage volume. We offer the ability for you to set up what we call API scanning, and this allows you to implement our scanning functionality programmatically within an application or web form or anything else that you have that processes customers' or users' files. What you can do on your side is you can have a function within your code that sends any uploaded files from your application or web form to this API endpoint that you stand up. This API endpoint is hosted within your ECS cluster within your AWS account as well. And the file can be sent to the API endpoint, it can be scanned, and a result will be returned. Based on that result, you can then have your application either upload the file somewhere, a storage volume or database entry, or really anywhere that you choose to upload it to. And then from there, if the file is found to be anything other than clean, you can deny the upload, show the user an error, or do whatever it is that you think is best if that finding were to come through as infected or error or anything like that. Our API scanning functionality is a great way to scan files before they ever enter your storage volume. So keep this in mind as you're going along, because it's a really, really powerful way to protect your data and minimize any downstream risk of infected files ending up in the hands of your customers or users or anyone else. One last area I will cover for today is the ability to be able to link in additional AWS accounts. When you deploy our solution, you stand up this single management console, and with this console, we'll ingest all of the storage volumes associated with the AWS account that the console is stood up in. But what you can also do is you can link in additional accounts. That way, you don't have to stand up separate management consoles across multiple AWS accounts. When you link in these additional AWS accounts, you can set the account ID, you'll deploy a cross-account role on that account, and what will happen is we will be able to ingest all of the storage volumes associated with each account that you've linked in. One thing to keep in mind for linked accounts is that anytime you've linked in accounts, we will scan files stored in those linked accounts on the scanning infrastructure that is hosted on your primary account where your AV console is deployed. Now, the objects will be scanned in the same region, so they won't be leaving the region, but they would technically be leaving your AWS account and be scanned on scanning infrastructure that's hosted in that primary account. So just something to keep in mind as you move along. That's just about everything for today that I wanted to cover to give you a really brief high-level overview of our solution and how it works. If you have any questions, just let us know, and thanks so much for your time.